So we will be moving on to the next term which we need to study in this chapter, that is acceleration. Acceleration. Okay, so when you are traveling in a car, okay, so your father or our brother, etc., they will be driving the car. They will be using there are 3 pedals under, means what, when under the driver's legs. Okay, so the one is brake pedal, the other one is clutch, and one more thing is there, accelerator, isn't it? So acceleration, what is, whenever they want to increase the speed, what they will do, they will accelerate, they will keep the legs on the accelerator. So what will happen, the car will move forward, isn't it? Okay, so what is acceleration? So acceleration means, it is in physics or in physical terms, what we will say is, it is rate of change of velocity. Rate of change of velocity can be said as acceleration. Okay, one important thing, what was speed? Speed or velocity can be said as change in position. Change in position with respect to time, isn't it? Change in position with respect to time is said as what? Speed. Clear? Change in position with respect to time is said as speed. Okay, so I will say once again, I will change the I will explain it in another terms. Okay, speed can also be said in another terms, that is rate of change of position. Rate of change of position can also be said as what? Speed. Rate of change of position can also be said as what? Speed. Okay, so listen, what is this term explaining? Rate of, what rate? With respect to time. What rate? There is some change in position with respect to time. So that change, the rate of change with respect to time. So whenever, important thing, whenever there is a term of rate of change of something, so then you have to keep in mind that rate of change of something, it will also always be related with what? It will always be related with the time, the quantity time. Okay, so whenever there is whenever you come to know, or whenever you come to hear there is a rate of change of something, then automatically it should come into your mind that that change in something is with respect to time. Clear? Okay, so here what will be rate of change of velocity then? So I have told you acceleration is rate of change of velocity. So what you can understand from the definition, how can you write the equation? Acceleration, we are denoting it by the letter small a. So acceleration A is what? I have told you, speed is rate of change of position. So change in position is the distance travelled. Change in position is the distance travelled. So rate of change of position means change in position divided by time. Distance by time, speed. So here, what is rate of change of velocity? Change in velocity divided by what? Time. Rate means always it will be with respect to time. Change in velocity divided by time. This is the equation for acceleration. This is the equation for acceleration. So acceleration means rate of change of velocity. So what is happening? At one interval of time, what will happen? The velocity will be this much. So the body is moving with some 10 meter per second. The body is moving with the speed of 10 meter per second or with the velocity of 10 meter per second. But after that, from the 1 to 5 minutes, seconds, it was moving with 10 meter per second. But in the next portion, from 6 to 10, so next to 5 minutes, it was moving with 12 meter per second. Okay, so the body has changed its velocity. So the term which helps us to find out what is the change in velocity with respect to time, that is called what? Acceleration. So imagine the body, the acceleration means what? In car, we'll accelerate. When we apply acceleration, the body moves its, means what? Changes its speed. It races more faster, isn't it? So in order to change the speed, we are accelerating. So whenever there is a change in speed or change in velocity with respect to time, we will call that quantity as acceleration. Keep in mind. You imagine, keep it in mind with respect to the motion in car. Okay, so we will accelerate, the body will change its speed, the car will change its speed. So likewise, acceleration means rate of change of velocity, that is change in velocity with respect to time, isn't it? So, and if we want to write it down in equation model, what we can do is change in velocity it is. So in a body was moving at an initial velocity. If a body is moving at a initial velocity before application of axle, means what? Before applying, means before changing force, the speed, it was moving with an initial velocity, maybe u. We will be in physics, in these chapters, we will be having the initial velocity. We will denote the initial velocity as small u. Okay, and after the application of acceleration, after some times, the body is moving with a final velocity. It has increased its velocity. It has increased its velocity, and it will move with the final velocity. What? We will denote the final velocity using the small letter v. Okay, so initially it was moving with u, finally it is moving with v. So what is the change in velocity? The change in velocity is equal to final velocity minus initial velocity. Okay, how much change the velocity, how much change has taken place in velocity? For example, if the body was moving with 10 meter per second at the beginning, and at a later time it was moving with 17 meter per second, finally it was moving with 17 meter per second. So what is the difference? The difference is 7 meter per second, isn't it? 7 meter per second is the difference in velocity. So that means how we got 17 final velocity minus 10 initial velocity, you got what? 7 meter per second, that is the change in velocity. Clear? Okay, so how can we write the equation? How can we write the equation? So equation can be written as A, acceleration A is equal to final velocity minus initial velocity, that is change in velocity divided by time. So this is the equation for acceleration. Clear? Okay, so acceleration is also clear to you. So acceleration is the rate of change of velocity, and the equation is final velocity minus initial velocity, that is altogether called as change in velocity divided by time. Clear? Now what is the SI unit? SI unit of acceleration, important. What is the SI unit of acceleration? How can we find out? What was the SI unit of here? Change in velocity. So the change in velocity itself, again it is what? Velocity itself, isn't it? So that quantity will help give you whatever it is. So I have told you 17 meter per second minus 10 meter per second will give you what? 7 meter per second. So that quantity, that term is again what? Velocity. So what is the SI unit of velocity? SI unit of velocity is meter per second. Meter divided by second is the SI unit of velocity, divided by what is there? Time. That is again what? Second. So denominator, what will happen? Meter per second square. So this is the SI unit of what? Velocity. We will write it as meter per second square, or and in other terms we will write it as meter second raised to minus 2, because we will take this s square to the numerator, then this s square will become s raised to minus 2. Okay, that's what I have written over here. So all are the same. All these three are the same. What is it? Meter per second square is the SI unit of acceleration. SI unit of acceleration. Clear? How to find out the SI unit? Whatever use the equation, substitute the numerators SI unit, denominators SI unit, you calculate it or you rearrange it, you will get the SI unit of the entity, whatever entity we are taking. So acceleration is also clear to you. Clear? Okay. So now, now we are moving on to the important point of this chapter. So motion you understood. What is motion? Change in position with respect to time. Okay. So speed, distance by time, velocity, displacement divided by time. Displacement, it will be helping us to find out the magnitude or the quantity as well as the direction. Then we studied acceleration, rate of change of velocity. Clear? Now we are moving on to the next portion, that is graphical representation of motion. Okay. We will be using graphs. Okay, you have studied it in mathematics, how to plot a graph, etc. using x-axis, y-axis, etc. Okay, so using graph, we will be representing the motion of everybody. We can represent the motion using graphs. Okay, so that's what we are moving, we are going to study in this portion. Okay, so the graphical representation of graph. First of all, you know a graph will be having an x-axis. In physics, in chemistry, in maths you have studied it, x-axis as well as y-axis. Clear? The graph will be having an x-axis as well as y-axis. Okay, so what is a graph? What is a graph? What is a graph? What is a graph? Graph is a picture, isn't it? It's a picture. So what it represents? The graph is pictorial representation of any observation. We will observe something, for example, when the body is moving. At the first 5 minutes, it moves a particular distance. Next 5 minutes, it moves a particular distance. Next 5 minutes, it moves another particular distance. So we want to understand what is the type of motion, or how it is moving in a better manner. So for that, we will be using what? Graphs. For example, when you are watching cricket, there will be bar diagrams will be shown, isn't it? In the first 1 to 10 overs, team A, for example, if it is England, team A, England has scored 70 runs in the first 10 overs. Then the next 10 overs, they have scored only 45 runs. Then the 20 to 30 overs, they have scored only 25 runs. Then the last 10 overs, 30 to 40 overs, they have scored 75 runs. Last 10 overs, they have scored over 99 runs. Okay, so that graphical representation will help us to find out how was the pace of the innings of England. Okay, and in order to compare it with India's point of scoring, India's way of scoring, they'll again show how much distance, how much score the India has scored from first over to the 10th over, 10 to the 20, 20 to 30, etc. Okay, so there will be a comparison. We can easily compare with how much pace the batsmen were scoring in England team as well as an Indian team. Clear? Okay, so graph is pictorial representation. Pictorial representation of what? Graph is pictorial representation of what? Of observations. Observations. So we will be having some values. We will be observing something. We will have some values. That values we will be inculcating into a graph, so that we will have an easier understanding, an easier comparison between 2 or 3 types of motion or 2 or 3 types of scoring runs, etc. Okay, so graph is a pictorial representation of observation. Clear? And what we will have? It will have 2 variables, x-axis as well as y-axis. So we will be taking some variable in y-axis, we will be taking some variable in x-axis. So out of these 2 variables, we have to note down that in x-axis we will be always taking what? Independent variable. We will be always taking independent variable. Independent variable in the sense, if we are that means whatever quantity we are taking on x-axis, with respect to that, what is the change in y-axis, that we will be plotting it. With respect to the change in x-axis, what is the change in y-axis, or what is the change in the variables here, that we will be noting down. Okay, so y-axis will be termed as dependent. In y-axis, we will be taking the variables which are dependent on the x-axis variable. Okay, so x-axis, with respect to x-axis, what is the change in y-axis, we will be plotting in a graph. Okay, so in x-axis we will always plot independent variable. When I give an example, you will understand it. In y-axis you will plot dependent variable. For example, let us take time. Time SI unit is seconds in x-axis, and we will be taking distance, that is meter, in y-axis. Okay, so 1, 2, 3, 4, 5, 0, 10, 20, 30, 40, 50. Okay, so listen. In the first second, 0 to first second, the body moved 10 meters. The body moved 10 meters. Okay, with respect to this time, what is the change in distance? What is the change in the dependent variable? Distance is dependent on time. Okay, so time is an independent variable, distance is a dependent variable. Clear? Okay, in the first second, the body moves 10 meters. From 1 to 2 again it moves 20 meters. 2 to 3 it reached 30 meters. So like this, if a body is moving from 0 meter, in the first second it reached 1 meter. So the distance is like this. So 1 meter, 2 meter, it is there. So the car is moving. It reached, when at first second it reached 1 meter. Then the next second it reached, second it reached, 10 meters, 20 meters. Second it reached 20 meters. Then the third second it will reach what? 30 meters. Okay, so that motion we are representing in a graph, and the fourth second it reached 40 meters, fifth second it reached 50 meters. When we are drawing a graph, what we will do? We will join the points. We will join the marks. So we will get a straight line. So this is a uniform motion. Okay, that I will say. So this is how we need to plot a graph. We will, with respect to time, what is the change in the dependent variable distance, we will be plotting it, and we will join the points, we will get a graph. This is called the graph. This line is the graph. This will represent how the body is moving. It is moving in a uniform manner. The increase in the speed or the increase in the distance with respect to time is constant. It is moving in a constant manner, isn't it? So we can say that this is uniform motion. Uniformly motion. For example, you just look in the first interval, time interval 0 to 1, it moved 10 meters. 1 to 2 again it moved total 20, that means the difference is 10 meters. 2 to 3 again it moved 30, 20 to 30, total 30, but before, from second to the third second it moved 10 meters. So the motion is, there is equal distance travelled in equal interval of time, so it is uniform motion. So this is the graph for a uniform motion. Graph for a uniform motion. Now, if it was not a uniform motion, what will happen? In 0 to first second it will travel 20 meters. Then from second to third meter it will travel 50 meters. Then maybe it will travel 70 meters. So the graph won't be a straight line. This will have different inclinations. Okay, so then we will understand that the body is not moving in a straight line. That means the body is not moving with uniform speed, it is moving with different speed. Clear? Okay, so this is how we need to plot a graph. Clear? Okay. So there are different types of graphs which we need to study in this chapter, that is velocity time graph, position time graph, then velocity position velocity graph, etc. So these different types of graphs we need to discuss in this chapter.